Hello everyone, welcome to the discussions of the past year question. This video we shall take a look at further Pure Maths Paper 2, October-November 2023, Paper 21. Let's take a look at the first question. Number 1, matrices. Show that the systems of equations as given here, where the k is a constant, does not have unique solution. Okay, we want to show that these systems of equation does not have unique equation solutions and interpret this situation geometrically. So in order to show that it does not have unique solution, we just might need to find the determinant. So the determinant of these systems of equation will be 14, 1, negative 21, negative 4, 1, 6, 6, k, negative 9. You cannot say is equal to 0. You need to show is equal to 0. So we just need to find the determinant. It will be negative 9 minus the 6k plus the 4 of negative 9 plus the 21k plus the 6 of 6 plus 21. So just use your calculator, expand everything. You get negative 126 minus the 84k minus the 36 plus the 84k plus the 162. So you can see that at the end is a 0 for all the value k. So the k, no matter what the value of the k is, you will always get the determinant equal to 0. So therefore, the systems of equation does not have unique solution. Does not have unique solution. Okay, then now we want to interpret this situation geometrically. So in order to interpret this situation geometrically, what you need to do over here is to observe these three equations. Okay, just observe these three equations. You can see that if you observe them one by one, equation by equation, you can see that the first equation and the third equations actually, they do have some relationship. Okay, so what we can do is that from the first equations, I am going to divide everyone by 2. So if I divide the first equation by 2, I get 7x minus the 2y plus the 3z equals to the 5 over 2. And the third equations, if I divide it by negative 3, then I will get 7x minus the 22y minus the 2y plus the 3z equals to the negative 14 over 3. So you can see that these two planes are parallel, but not identical. So you have these two planes are parallel, but not identical. Okay, so over here, what you need to mention over here in the descriptions, just want to interpret this situation geometrically. You just say that you have two parallel plane, but not identical. The other plane is not parallel. The other plane is not parallel. So you have plane number 1 and plane number 2. They are parallel but not identical. Then the plane number 1 and plane number 3 are not identical but parallel. But the second plane is not parallel to any one of them here. So this will be the answer for the question number 1. And move on. Question number 2. So now we move on to the question number 2. We are looking for the root. Find the roots of the equations given here, giving your answer in the form of polar form, where the r greater than 0 and the theta is from 0 to 2 pi. Okay, so this information given over here, what you need to do is you just need to apply the root of the complex number formula. But first of all, we need to convert the 4 plus 4 is 3i into the polar form. So z plus 5i, I just leave it. So this one I change it to the polar form. So in order to change the polar form, I just take the x out, then I get a half plus the 3 over 2i. Then x is the modulus. Then the half, it will be the cos pi over 3 plus I sine pi over 3. You can just apply the result directly. Then the z plus 5i, you need to cube root the whole thing here. For the cube root, now I apply the De Moivre theorem. So I have zk plus 5i is equals to the 2. Then you have a cos of pi over 3 plus 2k pi over 3 plus the I sine of pi over 3 plus 2k pi over 3, where the k is 0, 1, and then 2. So when the k equal to 0, then you have a z0 equals to the 2 cos of pi over 9 plus the I sine pi over 9 minus the 5i. So you can write into this form. Okay. So if you want to write into this form, then it will be I 2 sine pi over 3 minus a 5. That is your first root. Then the second root will be k equal to 1. K equal to 1, you will have z1. Then over here, just direct apply the k, put the k equal to 2 inside, then straight away write out the answer. So this one, it will be 2 cos of k equal to 1. So you will have 7 pi over 9 plus the I sine 2 sine. Seven pi over 9 minus a 5. And the last one is when the k equal to 2, sec2 will give you cos 13 pi over 9 plus the I 2 sine of 7 pi over 9 minus 5. Done. That will be the answer for the 3 roots over here. Okay, so that will be the answer for the number 2. Move on. We have question number 3. Now we take a look at question number 3, Maclaurin series. Find the first 3 terms in the Maclaurin series for the arctange of half e power x in the form of half ln a plus bx plus cx squared, giving the exact values of the constant a, b, and c. So for these questions, we cannot apply the formula from the MF19 directly. We need to do the differentiation because arctange and e power x, they all have their own Maclaurin series. So we're not able to combine them together and do it. It will be very troublesome if we combine them together. So what we need to do is we let this as a fx, arctange of half e power x. So what you need to do is to differentiate this. So this one, you can refer to the MF19 formula booklet, MF19 for the differentiations. You're supposed to get this. So if you differentiate from the formula booklet directly, okay, then simplify it, multiply everyone by 4, you get 2e power x divided by the 4 minus the e power x, e power 2x. Then you need to do until x squared, so you need to do until second derivative. So just do the product rule, keep the bottom, differentiate the top, minus keep the top, differentiate the bottom, divided by the bottom square. Okay, so actually if you want, you can simplify the second derivative, but I know that second derivative will be the last one I need to do. So I don't think I need to I do not think I need to simplify it. So what I need to do is to put 0 inside. I get a tanh of the half. Refer to the formula booklet. The inverse hyperbolic function can be represented in ln. Then it will be half of the ln of 1 plus half divided by 1 minus half. Simplify it, you will get half ln 3. Okay, that will be f0. Then the f prime of 0, you will get 2 over the 4 minus 1, you get a 2 over 3. Then the f double prime of 0, you will get 4 minus 1 times 2 minus 2 times negative 2 divided by the 4 minus 1 power 3. Press the calculator, you will get 10 over 9. Okay, so now we are ready to do the Maclaurin series. Fx equal to the f0 plus the f prime 0 x plus the f double prime of x squared over the 2 factorial. Okay, then this one is a half ln 3. Now this one I think I will use an approximation sign. Okay, I will use approximation sign over here. So this one, it will be arctangent of half e power x is approximately equals to half ln 3 plus 2 over 3x plus the 10 over 9 of x squared over 2. Then it will be equal to the half ln 3 plus the 2 over 3x plus the 5 over 9x squared. Done. That will be the answer for the question number 3. On question number 4. Okay, now we take a look at question number 4. Find the particular solutions of a differential equations, second order differential equation over here, given that x equal to 0, y equal to 2, and dy dx equals to negative 8. So what you need to do is to, first of all, convert the differential equation over here, make it become auxiliary equation, AE. Then I will get m squared plus 2m plus 3 equal to 0. We cannot factorize it. Just use the quadratic formula. You have a negative b plus minus of b squared minus the 4ac divided by 2a. Then you will get this one as a negative plus minus of 2i. So from here, you will get your contemporary solution. It will be e to the power of negative x a cos 2x plus the b sine 2x. Okay, so this will be the yc. Then now we let our particular integrals. We just let our yp. This is a quadratic, so we assume that this one will be a px squared plus qx plus r. Then your yp prime equals to 2px plus q. Your yp double prime will be 2p. Then substitute them inside these equations. you will get yp double prime plus the 2yp prime plus the 3yp equal to the 27x squared. Substitute and compare, you will get this 2p plus the 2 times 2px plus q plus the 3 of the px squared plus qx plus r equal to 27x squared. Simplify it, you have a 3px squared plus the 3q plus 4p x plus the 2p plus the 2q plus the 3r equal to 27x squared. By comparison, you have a 3p equal to 27, then you are having p as a 9. Then you have a 3q plus 4p equal to 0, then you have a q equal to the negative 4 over 3p, that will be negative 12. Then you will have 2p plus 2q plus 3r equal to 0, that you are having the r is equals to 3r is equal to the negative 2p minus the 2q. Then press the calculator, you get your r as a 2. Okay, your r is a 2. So that means your yp will be 9x squared minus 12x plus 2. Your general solution will be the yc plus the yp. Then it will be e to the power of negative x, a cos 2x plus the b sine 2x plus the 9x squared minus 12x plus 2. That will be your general solution. But the question giving you some initial value here. So we need to make use of this information in order to find the unknown a and b. So we need to find a dy dx first. So our dy dx will be keep the left, differentiate the right. Plus 18x minus 12. Hey, sorry. Keep the left, differentiate the right. I forgot to keep the right, differentiate the left. Just write a negative e power negative x over here. Minus the e power negative x. Then plus with the 18x. 9x squared minus 12x plus 2. So if you differentiate it, you will get 18x minus 12. Okay. Just hold on for a while. Okay. So this one, it will be 18x minus 9. Okay, now we are ready. Given when x equal to 0, the y is equals to a 2. So from these equations, 2 is equals to the e power 0, a cos 0 plus b sine 0 plus 2. So over here, you will get a is equal to 0. If you simplify it, you will get a is equal to 0. Then also given when x equal to 0, your dy dx equals to negative 8. So from the equation that we have found just now, over here, substitute this inside. Dy dx equal to negative 8. Then you will get e power 0 negative sub 2a multiply 0 plus the sub 2b multiply 1 minus the e power 0 of a times 1 plus the b times 0 minus the 9. Okay, so we simplify it. We'll get sub 2b minus the b minus the a minus the 9. A is a 0. Wait for a while. 18x minus 9. X equal to 0. Negative 9. Oh, I make a mistake. This is negative 12. Differentiate this is not negative 9. It's a negative 12. So this is a negative 12. And therefore, you can find that your B is equals to the 4 over sub 2. 4 over sub 2, you can make it become 2 sub 2. Okay. Then, therefore, your particular solution, y will be equal to e to the power of negative x. A is a 0. You only have b left plus the 9x squared minus the 12x plus 2. That will be the answer for this question number 4. Done. Now we move on to question number 5. Okay, now we take a look at question number 5. The curve C has the parametric equation given as following here. For the d from 0 to 3, find the exact length of C. So to find the exact length of C, first of all, we will be using this formula from 0 to 3, integrate dx dt square plus the dy dt square. Okay, so since we're going to use this formula, that means that at the very first step, we should find the dx dt and the dy dt first. So differentiate the x with respect to t. You have the t power half minus the t to the power of negative half. And then dy dt, you have 2. Then the square root of dx dt square plus the dy dt square. It will be t to the power of half minus t to the power of negative half square plus the 2 square. Okay. Then expand and simplify. You will get t power 1 minus 2 plus the t to the power of negative 1 plus 4. You will get t plus 2 plus the t power negative 1. Factorize it again. You will get this with the square. So the square and the square root can cancel off. At the end, you get t power half plus t to the power of negative half. Okay, so now we are ready to find the length of the curve C from 0 to 3. So just write down the formula, dx dt square plus the dy dt square. Since we have found the result of the square root of dx dt square plus the dy dt square previously, so we can just apply this result directly. Integrate 1 by 1. You will get this as a 2 over 3 t power 3 over 2 This one plus a 2 times t power half. The value is from 0 to 3. If you put 3 inside, this is what you get. Minus a 0. Factorize the 3 power half out. You get 2 over 3 times 3 plus 2. At the end, you get 4 over 3. So this will be the answer for the exact arc length of the curve C. Done for this question number 5A. Move on, question number 5B. We want to find the set of the value t where the second derivative is greater than 0. So first of all, in order to get the second order derivative, we must find the first order. First order is dy dx. Okay. So we find the dy dx first. Dy dx is actually dy dt divided by the dt dx dt, which is the 2 divided by the t power half minus the t to the power of negative half. So I multiply everyone by t power half. Then I get 2t power half divided by the t minus 1. This will be your dy dx. Then after that, we want d square y ds square. Applying the chain rule, changing the dx over here become dt. Then you multiply by the dt dx. Okay, so by changing them into this way, you will have d dt 2t power half over the t minus 1. dt dx. So dt dx, it will be 1 over the t power half minus the t power negative half. So this, we can do it first. Then as for this one, we can multiply by t power half and t power half like just now. So what you can do here is that the differentiations, keep the left, differentiate the right, minus, keep the bottom, differentiate the top, minus keep the top, differentiate the bottom, divided by the bottom square. So this one I get t power half, t minus 1. Then expand and simplify. You will get this as the negative t power half minus the t power negative half over the t minus 1 square. So now I combine them together, will become t minus 1, t plus 1 over the t minus 1 cube. Oh, okay. So what we want over here is that we want that the square y, the x square will be greater than 0. That means that the negative of t plus 1, t minus 1 cube must be greater than 0, which is the t plus 1 and the t minus 1 cube is less than 0. Okay, so from here, you can see that we can have a quick check. This is a negative 1, this is a 1. So from here, you can see that if you want it to be a negative, then your answer will be here. Your answer will be here. Okay, so your t will be between negative 1 and 1. But because of the t given in the questions is from 0 to 3, therefore your t will be like this. Okay, you can see that the questions telling you that the t is from 0 to 3. Okay, so your answer will be this. Done. Okay. Oh, sorry, this one is including 0. Not aware of it. Because if you put 0 inside, then you will get negative. So the 0 is included. Okay, now we move on to the question number 6. Okay, now we take a look at question number 6a. Starting from definitions of cosh and sine in terms of exponential, prove that this identity is true. So what you need to do over here is that you can actually start from the left-hand side or the right-hand side, which is up to you. So over here, I think I will start from the left-hand side. So it will be sine 2x. If you use the definitions of the exponential form, then you will get e power 2x minus e power negative 2x divided by 2. And you can actually factorize that, become e power x plus e power negative x, e power x minus e power negative x divided by 2. Okay, so that means I'm using the formula a squared minus b squared. I factorize it, become a plus b, a minus b. Okay, then over here, I just need to split them. That means this one, I will split it, become e power x plus e power negative x over 2. This one, I have e power x minus e power negative x over 2. Then I multiply a 2 here, so that I will get back the previous equations. Then after that, what I have over here is a cosh. What I have over here is a sine. Okay, so I just write it as a 2 cosh x sine x. But the question one, sine in front, cosh at the back. Well, actually, it's the same. So this one is equal to your right-hand side. Proven. Okay, so this is how you prove it. Then now we move on to the B. Use the substitutions u equal to sine x. Find these integrations. So what you need to do is that first, for the substitution, we always differentiate the substitution at first. So differentiate sine, you will get cosh. Then your du equal to the cosh x dx. So that means this question's sine square of 2x cosh x dx. I can change this whole thing to become a du. Okay, but I cannot change yet because what I have over here is sine 2x, not x. So I need to settle this part first. I need to settle this part first before I do the substitution. So what I need to do here is that make this sine from the part A. We know that sine 2x is a 2 sine x cos x square. Then it will get 4 sine square x cos square x. And then cos x dx. So you can see that this one, I still keep it in this way. I don't plan to combine together become cos cube. I just leave it as a cos dx because I am ready to make this become du. So now you can see that this will become a du. This will become a u square. This, I have to use a formula of the hyperbolic identity. Cos square is actually cos square is actually 1 minus sine square. Okay, so you can write the cos square as 1 minus sine square. So this one you can make it become, this one copy down only. This one you make it become 1 minus the sine square. Oh, I make a mistake because this one is easily make mistake because trigo in trigo we have cos square plus sine square equal to 1. In trigo we have cos square plus sine square equal to 1. But over here this one is hyperbolic, not trigo. So it will be, the formula is supposed to be cos square minus a sine square equal to 1. So cos square is actually plus. This is not minus. It's a plus. So you have to be careful when you use this formula. So now we are ready to make this one become 4u square, 1 plus u square, and du. Now we can integrate the whole thing. So what you need to do is actually just expand them only. You get 4 over 3 u power 3 plus a 4 over 5 of u power 5 plus c. Change the u become sine. Then you get this result back. Done. That will be the answer for this part B over here. Okay, so now we want to move on to the next question, C. Find the particular solutions. Okay, we are looking for the particular solutions of the differential equation. So for the particular solutions of the differential equations, what I need to do is that this is considered as a linear equations. We will need to use integrating factor for the tangent x. So first of all, we find the IF, integrating factor. It will be equal to the e to the power of integrate tangent x dx. So integrate tangent x, you will get ln of cos x. Okay, just like that. No need to put a plus c. Then e power ln of cos, it will be equal to the cos x. That will be your integrating factor. Then you multiply the integrating factor into all of them here. So you multiply everyone by the integrating factor. Then you will get cos x dy dx plus the y sine x equals to the sine square 2x cos x. Okay, so this is the result after you multiply these equations with the integrating factor. So from here, the integrating factor and the y, you can just combine them together. What I'm going to do in the next step is to integrate both sides. So to integrate both sides, this one, since you have multiplied the integrating factor, this one just multiply with the y will do. This one just need to integrate sine square 2x cos x dx. So from the result in earlier, from the result in part B, okay, you can refer the result in part B over here. This result, just copy down this result and you solve the right hand side. So you can solve your right hand side easily by just copy down the result in the part B. However, if your answer in the part B wrong, then it will affect your answer over here. So it will be cos y equal to the 4 over 3 sine cube. This one is a 4 over 5 sine power 5x plus a c. Okay, then the question giving you the initial value when the x equal to 0, y equal to 4. When x equal to 0, y equal to 4. So this one you need to use calculator. Cos 0, 4. Then this one is a 4 over 3. Sine 0 is a 0. Okay, you should understand that sine 0 is a 0. Of course, you can use calculator to press it. Okay, Then a cosh 0 is a 1. So your C is a 4. Okay, C is a 4. Then therefore your cosh y, cosh x multiplied by y, it will be equal to the 4 over 3 psi cube x plus the 4 over 5 psi power 4x plus a 4. Then your y, if you the cosh, if you bring over here, it will be divide cosh, you will get sec x multiplied by the whole thing. I do not plan to expand anymore. I just leave it as a factorized form will do. So this will be good enough. Of course, for those who want to have a more perfect answer, you can actually factorize the 4 out, but I don't think it's necessary. There's no need for you to factorize the 4 out. Okay, it's okay to leave it like that. So this is good enough. So now this is the answer for the C. And okay, done. This is the answer for the question number 6. And move on, we have question number 7. Okay, now we take a look at question number 7. The matrix A is given by the matrix over here. Then find the matrix B and the diagonal matrix D such that the A inverse equal to the BD inverse. Okay, so for this question, very obvious, we need to find the eigenvalue and the eigenvector for the matrix A. So first of all, we find the eigenvalue for the matrix A. So you can see that because of the triangle here, all the lower triangle here, all 0. So you don't need to show how to find the eigenvalue. You can just straight away write the eigenvalue is equals to the diagonal here. All the element in the diagonal here, -6, -2, and 8, they are the eigenvalue. You can straight away write it like this. Okay. So eigenvalues, I will call the eigenvalue as lambda. I will use a symbol lambda to represent them. So when the lambda 1, okay, -6, then I need to find the determinant, non-determinant. Okay, so A minus, I think maybe we no need to write like this first. I need to show the A minus lambda I first. So A minus lambda I, it will be -6 minus a lambda 0, 0, 0. Only the diagonal are affected. Only the diagonal are affected. The rest just copy down. So when the lambda 1 equal to -6, okay, then the A minus lambda I, it will become, or maybe you can say -6i, minus -6, minus -6, it will become plus 6. So you will get 0, 0, 0, 2, 4, 0, 13, 5, and then 2. So you can see that I will use these 2 of the matrix over here to find the eigenvalue. Okay, so I will use these 2 row, find the determinant. Okay, so I will take the I, J, K. The second row value is a 0.45. The third row is a 0.02. And then just do the cross product, then you will get 8i. 8i means you can write it as a 8, 100. That means my eigenvalue number 1, it will be called 100. Okay. Same thing happened for when the lambda is lambda, the second value for the lambda is a -2. So when it's a lambda -2, then your A plus 2i, then it will become -4, 0, 0, 2, 0, 0, then 13, 5, and 10. So I will use the first and the second row to find the eigenvalue, eigenvector. So this one is negative 4, 2, 3, 0, 0, 5. Then do the cross product. You will get 10i plus 20j. Oh, okay, see the k is a 0. So you can take the 10 out, then you get 1, 2, 0. That means my eigenvector number 2 will be 1, 2, 0. Okay. Now we go for the third lambda. The third lambda is a 8. So your a minus 8 lambda will be equals to negative 14, 0, 0, 2, negative 10, 0, 13, 5, 0. So over here, we just take the first two. The last row, definitely we're not going to use it because the last row all 0. So over here, we will find the cross product. Negative 14 to 13, 0, negative 10, and 5. Do the cross product, you will get 140i plus 70j plus the 140k. So this one actually can be written as all can be divided by all is a fact multiple of 70. So I just take the 70 out, you get 212. So means my eigenvector for the number 3 will be a 212. Just like that. So from the eigenvector that we have, you can group them together. Your P will be E1 is 100, E2 is a 120, and then E3 is a 212. That will be your P. Then as for the A inverse, PD, P inverse, so this actually the formula is belong to the diagonal. Okay, that means this one is supposed to be inverse. Okay, so it will be the diagonal, the inverse of a diagonal. Okay, so it will be this one. It will be B. Okay, maybe we will do it this way. Okay, our diagonal. Let's say I call this diagonal a vector B. The diagonal is this. Diagonal is lambda 1. Lambda 1 just now was negative 6. Lambda 2 was negative 2. Lambda 3 was 8. So this is the diagonal matrix. Okay. So for this relationship to fulfill, then your D will be the B inverse. B inverse will be D is equal to B inverse. So therefore, your D is equal to the negative 6, 0, 0, 0, negative 2. So for the diagonal matrix, you can actually make it become power negative 1 directly. So only diagonal matrix have this behavior. So we can actually change it like this directly. That is the matrix D. Okay, done for the part A. So now we move on to the part B. Use the characteristic equations of A to find the A inverse. Now we want to find the A inverse. So to find the, use the characteristic equations to find the A inverse. So first of all, you need to understand what is the meaning of characteristic equation. So characteristic equation, just take your lambda, the lambda just now, this one is plus 6. Actually, to find the characteristic equation, just take the determinant of the A minus lambda I equal to 0. Okay, just take it like this. This is the formula to find the characteristic equation. But we already have lambda. So that the lambda just now was this. So actually, we just need to go backward. Just take the lambda plus 6, lambda plus 2, and lambda minus 8. If you extend them, to save time, I will expand it directly. So over here, Okay, never mind. I think I will show you how to expand it. So if you expand it one by one, you will get lambda squared plus 8 lambda plus 12, and then lambda minus 8. Then you get the lambda cube plus the 8 lambda square plus the 12 lambda minus the 8 lambda square minus the 64 lambda minus the 96 equal to 0. So at the end, simplify, you get lambda cube. Lambda cube. This one cancel, no more lambda square. Then you only have negative 52 lambda minus the 96 equal to 0. Okay, so this is called the characteristic equations. And in order to use the characteristic equations to find the A inverse, we will use the CAIE-Hamilton theorem. CAIE-Hamilton theorem says that from the characteristic equations, we can make it become A cube. The lambda change to the matrix A, and the 96, you make it become I, 96I. Then you get a matrix 0. So you will be getting the 96I equals to the A cube minus the 52A multiplied by the A inverse. You will get 96A inverse equal to the A square minus the 52I. So just use the matrix algebra. So your A inverse, it will be equal to 1 over 96 of A square minus the 52I. Okay. So now we have the relationship already, but they want the matrix, so I need to show the A square. So over here, we need to show A square. A square is these two matrices multiplied together. So A square, A square was negative 600 to negative 20. Negative 600 to negative 20. Negative 600 to negative 20. And what? 13, 5, and 8. 13, 5, and 8. Okay, so 13, 5, and 8. 13, 5, and 8. So if you need to show the product of A square, okay? So how to get the A square? So A square, if you expand directly, 3600, negative 1640, and 36, 30, and 64. If you expand it, then therefore your A inverse will be equal to 1 over 96. The A square, write down. The 52I, 52, 0, 0, 0, 52, 0, and 0, 0, 52. Expand, simplify. You will get this answer. Simplify directly now. So negative 1 over 6, 0, 0. Negative 1 over 6. Negative half. And then 0. 3 over 8. 5 over 16. And 1 over 8. That will be the A inverse. Okay, this will be the answer for the part B, the A inverse. So this is the answer. Then move on. So I'll move on is question number 8. Okay. Now we take a look at question number 8. Complex number, part A. State the sum of the series z plus 1 plus z plus z squared plus until z to the power of n minus 1. So this one is obviously, this one is a GP. Your first term is a 1. Your common ratio is a z. And you have how many of them? You have terms, n of them. You have n terms. So for this question, just apply the Sn formula for the geometry progressions. So you will get this 1 plus z squared plus until here, it will be equal to the A z to the power of n minus 1 over the z minus 1. Okay, so you can write this one without the 1. You can actually write like this, z power n minus 1 over the z minus 1. Done. And z cannot be 1. Okay, so this will be the answer for the part A. Done. Then part B. Part B will be a bit long because 7 marks. So for part B, the question giving you z equal to the cos theta plus I sin theta, and then they want you to do this, show that this relationship is the same. This relationship is true. So how do you show? Okay, so what you need to do is that must be related to the part A. So since part A just now we found the sum of the z. So what I will do over here is that I will write like this. They already told us that the z is equal to the cos theta plus I sin theta. So what I need to do is I need to write this as a z power of r. The r start from 0 and then until n minus 1. Okay, because following this statement in the part A, the r start from 0. The power start from 0. Okay, maybe I don't use r because if I use r, it will be confusing with the common ratio. Maybe I use k. Then that means this one, it will be the same as a z to the power of n minus 1 over the z minus 1. So over here, I want to, this one we know that this one is complex. Okay, I want to realize the complex. I want to make it realize it. I want to make the denominator become real. So in order to make the denominator become real, I will just need to multiply the conjugate of the denominator. So the conjugate of the denominator will be like this. Okay, so over here, we will just apply the property of the conjugate z minus 1 conjugate. Okay, your left-hand side, now I can write the z as a cos theta plus I sin theta. Okay, I can write like this. My right-hand side, my numerator, I will remain it unchanged. This one, you need to know that we have a property for the conjugate to be a z conjugate minus 1. Okay, so this one actually we have discussed before in our lesson. So this will be the z conjugate minus 1 over the z minus 1 multiplied by the z conjugate minus 1. Then my left-hand side, apply the de Moivre theorem. If you apply the de Moivre theorem, you get cos k theta plus I sin k theta. Okay, de Moivre theorem. Okay, de Moivre theorem. Then no need to mention, just write like this will do. Then your right-hand side, I still do not want to use a cos theta and I sin theta yet because I want to make sure that I able to get the denominator become real. So I get this. Okay, so this is what I will have. Okay, this one is bracket and plus 1. Okay, so if I expand it this way, then I need to highlight over here because the z is given as this. So the z conjugate is cos theta minus the I sin theta. Need to clarify first. Therefore, z multiply z conjugate will give you cos square theta plus sin square theta will give you a 1. Then the z plus z conjugate will give you z plus z conjugate will give you the 2 cos theta. Will give you the 2 cos theta. So with this, after we declare this result, then we can actually continue with the series over here. Cos k theta plus I sin k theta is equals to the cos theta plus I sine theta power n minus 1 multiplied by the cos theta minus the I sine theta minus 1 divided by the 1 plus the 2 cos theta plus a 1. Okay, so we can write like this. Then what you need to do now, because the questions over here, you can see the question, they only want to see cos. So very obvious, they want to consider the real part. They want to consider the real part. So I will not going to do anything with the left-hand side already. Left-hand side, I will just leave it. So my right-hand side, I will use the Moivre theorem again to bring the power down. Okay, I bring the power down by using the De Moivre theorem. So over here, I will write cos theta minus 1 minus the I sine theta. Gather all the real part together. This one I will write it as a 2 plus 2 cos theta. So now focus on the right-hand side. We want to take the real one. How to take the real one? So to take the real one is, of course, this one, my apologies. I supposed to write minus 1 together over here. I suppose to write cos n theta minus 1 plus I sine n theta. Okay. So this is a real. This is a real. So I want these two multiply together. Okay. And then you can see that the I, and the I, if I multiply them together, I also will get real. So I only want the real part. Okay. So now if you get the idea, I just want the real part. If I take the real part out, my left-hand side will only be this. Forget about the I sine k theta. Okay. Then this one, it will be cos n theta minus 1 multiply the cos theta minus 1, then plus the sine n theta sine theta. This will be a 2 plus the 2 cos theta. So this is what I need to take out first by considering the real part. So now, before we continue, let's take a look at the question again. The question wants to see something like this. Okay. So my right-hand side still have a long way to go. So I need to, oh, my apologies. This is a minus. So then this is a minus. I make a mistake. Just notice it over here. So this one is a minus. So if this is a minus, then this one I have to change it. This one is a minus. Okay. Now I just expand. Hopefully we have enough space to expand everything. Okay. So I have a cos n theta minus the cos theta minus the cos n theta plus a 1 plus a sine n theta sine theta. Actually I no need to do like this because you can see that I do not need to do like this. Okay, all I need to do is just to factorize the 2 over here out. Okay, so over here you need to have a very good observations with the with what the answer you have and what the question want. So you can see that this and this actually are same, but just that they are different order. So what you need to do is, if you refer to the questions, the question 1 minus cos theta. So if the question 1, the 1 minus cos theta, that means this one, I will factorize a negative out. So if I factorize a negative out, then I will get this. I will get this as a negative cos n theta minus 1 1 minus the cos theta divided by the 2, 1 minus cos theta plus the sine n theta sine theta divided by the 2 of 1 minus cos theta. So now this one can cancel. Then you get take a half out. Okay, so if you take a half out, then you get negative of cos n theta plus 1 plus the sine n theta sine theta over the 1 minus cos theta. Okay, then just need to reverse the process. I mean, just need to put the 1 in front, the cos and theta behind, then you can get the answer already. So therefore 1 plus cos theta plus cos 2 theta plus until cos n minus 1 theta is equal to the half 1 minus the cos n theta plus the sine n theta sine theta divided by the 1 minus cos theta. Okay, done. Shown. Okay, so over here, stop at here, we just say shown. Okay, done. Quite troublesome. Huh? So this will be the answer for the part B. Now we move on to the part C. Part C, this one is the summation of the series over here. Summations of the area of the rectangle here. The diagram shows the curve with the equations y equal to cos x, where the x is set from 0 to 1, together with a set of n rectangles with a width of 1 over n. So by considering the sum of the areas of rectangles, show that this relationship over here holds. So over here, what you need to do is we just need to show that the area, the exact area is the integrations of cos, but it's less than. That means we need to take a higher rectangle. Take a higher rectangle. So the higher rectangle, the height is f1, f0 multiplied by 1 over n. And then after this one is f0. After that, it will be f1 over n. After that, it will be f2 over n. Okay? So you're supposed to write like this. You're supposed to write f0 multiply 1 over n plus f1 over n multiply 1 over n plus f2 over n multiply 1 over n plus until, what is the last one? The last one is f n minus 1. So this one, it will be the same as a 1 over n of the, okay, first of all, I forgot to mention let fx equal to the cos x. Okay, so this will be the same as the series. K equal to 0 until the cos k over n. Cos k over n. Okay, so this one is actually refer to the answer in the part B. Answer in the part B. Okay, so over here, answer in part B just now was k theta, right? Answer in part B just now was k theta, right? So that means the theta is a 1 over n. Theta is 1 over n. So you change all the data in part B, change all the data become 1 over n will do. Okay, so change all your data become 1 over n. So you will get this. Okay, so therefore you have 1 over n multiplied by half of 1 minus the cos n over n plus the sine n over n, and then sine 1 over n divided by the 1 minus the cos 1 over n. Okay, then simplify it, you get 1 over 2n, or 1 minus cos 1 plus the sine 1 over n divided by the 1 minus cos 1 over n shown. Okay, so this is how you use the result in part B to do it. Definitely you need to use the result in part B. If you cannot use it, then don't know how to use it, then you cannot get the answer. Then use a similar method to find the upper bound at the lower bound. So the lower bound, that means integrate this. This time you will be greater. Okay, you have to be greater already. So if you greater, that means you need to choose the shorter rectangle, the rectangle with the shorter height. So the rectangle with the shorter height, it will be this, and the last one will be this. So your first height will be f1 over n. Your second height will be f2 over n. And the last height will be fn over n. Okay. So this one over here, just need to do it like this. You just need to write it down as a, make it like this. F1 over n plus F2 over n plus until Fn over n. Okay. So this one, it will be, we will make it like this, plus F0 over n plus F1 over n plus until Fn minus 1 over n plus a F1 minus a F0. This one, I cancel it because I want to go back to the same, one. So I just actually, I add F0n over here, and then I minus F0n at the end. Okay, I just add it at the beginning and minus at the end. Okay, so I need to do it like this. Oh, sorry. Everything must put under here first. Put under the bracket here first. Then I only expand the 1 over n inside. Plus until Fn minus 1. Then plus the 1 over n of F1 minus F0. Then this part, the whole thing is exactly over here, exactly the same. Just copy down. Then this one, it will be 1 over n, 1 over 2n. Just copy down the result in the part C. So this result will be 1 minus cos 1 plus the sine 1 over n divided by 1 minus cos 1 over n. Then plus the 1 over n. What is F1? F1 is actually cos 1. Then what is the F0? F0 is a cos 0. Cos 0 is a 1. Okay. So over here, you can see that they are having 1 over n here. You are having 1 over 2n over here. And in order to combine them all together, you will have to multiply 2 here. Then if you combine everything, okay, wait for a while. Okay. Hey, sorry. I need to erase this. So if you combine them together, everything together, factorize the 1 over 2n out. So then this is a 1 minus cos 1 sine 1 over n divided by the 1 minus cos 1 over n. Just copy down only. Then this one have to times 2. So you have 2 cos 1 minus 2. The whole thing here times 2 here, times 2 here. Then join together. You can see that these two will join together. These two will join together. At the end, your answer will be, do we have enough space over here? Okay, so I write it over here. So at the end, your final answer will be 1 over 2n. Maybe at the end, you can say that therefore, integrate from 0 to 1 of cos x dx is greater than 1 over 2n. So this one is the cos 1 minus 1 plus the sine 1 over n divided by the 1 minus the cos 1 over n. Okay, done, finally. Okay, so this will be the answer for this question number, this is the number 8. Okay, and this will be the last question already. So I stop the video here. Bye-bye.